Scattered across the cosmos are some of the strangest objects we've ever seen, with gravitational attractions so extreme, not even light can escape their pull. What are these objects, you ask? Black holes. So this week on Space Chat, I will be chatting and taking questions all about these strange objects. What are black holes? How do they form? And so much more. Now, if you're new to Space Chat, this is the weekly show where I hop on to answer your questions and take a deeper look at Earth, the universe, and beyond. So without further ado, let's dive into it. What are black holes? Well, first off, they're not holes. Black holes are extremely massive and incredibly dense objects. Their amazing amount of mass gives them an extreme gravitational pull that nothing can escape from if pulled within a certain range, even light itself. Hence, black holes. Light cannot even escape their pull. Now, the term black hole was coined in 1967, but black holes were considered as a possibility in some type of way as early as the 1780s. And the object's existence was first formally predicted in 1916 by Albert Einstein in his general theory of relativity, which described gravity as a result of distortions in the fabric of space-time, and therefore predicted how space-time would be warped by the extreme mass of a black hole, right? Imagine that giant marble, that giant, massive, dense object on a piece of fabric, the fabric of space-time, distorting it as it rolls and moves. But it wasn't until 1971 that the first official black hole discovery was made. Now, black holes have three layers. Two of these layers are an inner and outer event horizon. The event horizon is the area around a black hole past which nothing can escape. Once you cross into the event horizon, nothing, not even light, can escape. So if you get too close, even to the edge, you might just get pulled in. Now, black holes also have an inner region where the object's mass is concentrated. This is sometimes also referred to as the black hole's singularity. Radiation falls inward towards the singularity, and a spinning black hole's spin stretches the singularity into a ring that creates a rim inside the black hole called the inner horizon. Now, also interestingly, while black holes typically grow and gain mass over time as they pull in mass and matter, dust and gas that swirls around them, again, anything that falls close enough to that gravitational pull, they're growing and growing and growing. Despite this, some black holes have been known to shrink. In 1974, Stephen Hawking theorized that black holes radiate small amounts of particles, primarily photons, in an almost evaporation, known as Hawking radiation, that can cause the black hole to slowly shrink over time or even totally vanish as these particles slowly evaporate, disperse. Now, so far, scientists have identified three different types of black holes: stellar black holes, supermassive black holes, and intermediate black holes. Now, stellar black holes are created when a star runs out of fuel. Stellar, star, you get the gist of it. Now, when this happens, when a star runs out of fuel, when it runs out of hydrogen, it's the end of its life, it might collapse into itself. Now, when that star is relatively small by cosmic standards, or up to 3 times as large as our sun, again, small by cosmic standards, that's still pretty big in my book, this collapsed stellar core can become a neutron star or even a white dwarf. But when a much larger star collapses, when a star larger than 3 times the size of our own sun, when that size of a star collapses at the end of its life, that extreme amount of mass compresses and can compress into a black hole. Remember, I said black holes are extremely massive but extremely dense? They have an enormous amount of mass, but packed in, compressed in tightly, extremely dense. So when you have a star with all that mass, all that matter, and it collapses in, that compression can create a black hole. Now, moving on to supermassive black holes, everybody's favorite, right? Supermassive black holes are found throughout the cosmos in the center of galaxies. In fact, we have one at the center of our own galaxy. Now, they can be millions or even billions of times as massive as our sun, but about the same diameter, making them not just extremely massive, but unbelievably dense. Remember I mentioned while these black holes are massive, they're so dense. So something about the size of our sun could have millions or billions times the amount of matter or mass within it. So, extremely dense, right? Now, scientists are still working to fully understand how such massive black holes are created, but once they do form, their immense mass has such an incredible gravitational pull that once they're so massive, they continue to pull in dust and gas and matter, anything close enough, and they continue to grow even larger. Now, there are a few different theories floating around of how do supermassive black holes form? Something that massive, something that incredible on such an unbelievable scale. Now, some think that supermassive black holes are created when smaller black holes merge together. Another theory is that large gas clouds might collapse to form these objects, or a third alternative, that a group of stars could all fall and collapse together into a singular supermassive black hole. Now, another kind of stranger idea that some scientists have had is that potentially clusters of dark matter could form these supermassive objects. But since scientists don't yet know exactly what dark matter is or what it's composed of because it can't be directly observed, at least yet, this last theory has some challenges. Now, lastly, our third type of black hole. Intermediate black holes are what you might call medium-sized black holes, in between stellar and supermassive black holes. Now, this third type is the most recently theorized, as scientists once thought that black holes could only be big or small. However, emerging research continues to show evidence for their existence, and in 2014, astronomers even found what they think was direct evidence of an intermediate black hole in a faraway spiral galaxy. Now, in 2019, something amazing happened. The first ever image of a black hole was taken by the Event Horizon Telescope collaboration. This collaboration linked up radio telescopes from around the world, combining their power into one force. And with this power, they were able to see the supermassive black hole that resides in the center of the galaxy M87, 55 million light years from Earth. That's pretty far. Now, in the image, you could see a bright ring with a dark center. That bright ring imaged is the bright disk of gas, right? Gas and dust swirling around the supermassive black hole, while the dark center is the black hole's shadow. It was an unbelievable and powerful image that has continued to spark endless more questions, curiosity, and exploration and scientific innovation. Now, that was a brief, albeit not that brief, overview of black holes. And now I'm going to get to my favorite part of Space Chat. I'm going to answer some of your questions. Alright, so you guys had some really great questions about black holes. Understandably so, they're really cool. So Craig on Facebook asks, what's the difference between a quasar and a supermassive black hole? That's a great question. So oftentimes the word quasar gets thrown around when we talk about black holes, and it can be confusing. Is a quasar a black hole? Are they related somehow? Are they the same thing? What's the difference? So quasars are always black holes, but not all black holes are quasars. Let me break it down a little bit further. I know that's confusing. So quasars are extremely bright, active galactic nuclei that are powered by black holes, right? The center of galaxies, they're fed by these supermassive black holes. In other words, quasars are supermassive black holes that are actively feeding on the material swirling around them, creating these bright emission jets. However, not every black hole can be classified as a quasar. Not every black hole has this disk that they're actively feeding on and actively emitting bright jets. So it's a little bit confusing. Quasars are black holes. in a way, but not all black holes are necessarily quasars. All right, I hope that helps. Jeanette on Twitter asks, how do scientists know what kind of stars just fizzle out versus the ones that turn black holes versus the ones that go supernova versus the ones that turn into supermassive black holes, right? How do scientists know what stars might become black holes? This is a really, really great question. And I mentioned a little bit about it before, but typically larger stars, and when we're talking about large, we mean more than 3 times the mass of our own sun. So in my book, that's pretty large. So very large stars are the ones that can collapse into stellar mass black holes. And that's simply because they have enough mass to create a black hole. The main hallmark of a black hole is they're just so massive. They just have so much mass compressed and packed in there. So to create one, you have to have that mass to start out with, right? You can't create that mass out of nowhere. So if a star has enough mass, once it collapses, it can form a black hole, to answer your question. All right. Donald asked in an email, since a black hole compresses matter into a singularity, and since string theory imagines multiple universes, is it possible that our universe began from a singularity in a black hole in another universe? Now, this question might sound like sci-fi, but this is actually a question that scientists have been asking. It's something that is not completely out of the realm of possibility. It's not pure science fiction. This is something that scientists are continuing to talk about and kick around as a genuine possibility. They've theorized whether or not it is possible that our universe actually arose just from the singularity or that central mass point of a black hole. Some have even suggested that every black hole in our universe has a universe within its singularity. Now, there has been no proof to confirm this. However, it's definitely something interesting to think about and interesting to continue exploring because the universe is strange, right? We're talking about all of these objects and all of these processes, and they're amazing, but they are strange inherently. And so while a question like this or an idea like this might seem totally science fiction, it's strange in the same way that the existence of black holes is strange. So because scientists have not completely ruled it out as a possibility, because it is still within the tangible realm of possibility, it is still something to be thought about. But there is no proof for this, at least yet. Interesting question though. All right, Stephen asks in an email, since black holes vaporize anything inside, does that energy create heat? How hot is a black hole? Is the event horizon the beautiful light that encircles the black hole? So this question is kind of about, what happens when things fall into a black hole, right? So you use the word vaporize. Things aren't necessarily vaporized when they fall into a black hole. They're not turned into vapor, but all matter that gets sucked into a black hole that gets too close to the event horizon, where the gravity just pulls them right in, get torn apart. And crushed by the gravity at the black hole singularity. Now, when I say torn apart, I don't mean like limb from limb, something gory or horrible. I mean pretty instantaneously torn into our most basic subatomic particles. Not just going from organ to tissue to bone. We're not talking about human anatomy. We're talking about breaking it all the way down beyond atoms into subatomic particles, pretty instantaneously. So yeah, pretty much anything that goes inside, that's gonna happen. Yeah, it's a little crazy to think about. Luckily, none of us are at risk of falling into a black hole, thankfully, unless we're already living inside of one. But great question, Stephen. All right, Becca on Facebook asks a really interesting one. How close are we to discovering and hopefully photographing a wormhole? So since we have not yet confirmed the existence of wormholes, we're not that close to photographing them. Hate to say, but wormholes are a concept derived from Einstein's theories and from the theory of fellow scientist Nathan Rosen. Together they theorized that the surface of a black hole could essentially bridge two different patches of space and connect them. They thought that it was possible that two massive objects in potentially later on thought two parallel universes or different points in space-time could be drawn to each other through gravitational attraction, right? And black holes have a lot of gravitational attraction. So you imagine the face of two black holes, all that gravity, and space-time, it's a sheet, right? Bending towards each other and connecting in the middle because of that gravitational attraction. And so what people have theorized that this might look like, if it existed, would be kind of a funnel, right? So these two halves, these two gravitational forces, these faces that you would enter on either side, supposedly, and then they would funnel into the middle, creating a bridge between two places in space-time that could be millions of light years apart, could be parallel universes, some people have thought. Now, wormholes are consistent in their basic most theory with Einstein's general theory of relativity. So they are not totally, totally nixed from possibility. However, they have yet to be discovered. But it's definitely something interesting to consider. All right, Jacob on Facebook asks, are there any more findings on the latest black hole merger discovered? I'm not sure exactly which merger you're referring to. Actually, in September of 2020, last September, as I'm filming this now, there was the most powerful black hole collision ever detected that was discovered from gravitational waves that emanated from the event and that we eventually, much later on, detected. Now, I'm not sure if there have been any additional papers or findings from the original detection of these gravitational waves, but scientists are consistently monitoring for such detections and continuing to pursue and explore events like this further, to find out exactly what collided, exactly how they may have formed, to really learn more about the very basic nature of the universe. So, if there haven't been any findings from those observations yet, I'm sure there will be. All right, Morris in an email asks, how do scientists even begin to study these bodies when we only just got a photograph of it a few years ago? This is a great point, Morris. So the first ever photograph of a black hole was observed in 2019. It's 2021 as I'm filming this, so that's pretty recently. And we didn't concretely discover black holes until 1971, it was just theory. So this is all relatively new. When we talk about the general concept of time and scale and scope, I mean, this just happened. This is brand new information. However, scientists had wondered about the existence of black holes all the way before the 19th century. Now, there are lots of different ways that scientists can study faraway phenomena, crazy, challenging observations like black holes, exoplanets, things like that, without necessarily having a picture of them or seeing them even directly. When we talk about black holes, we talk about that gravitational pull, right? That intense gravitational pull. And so one way that scientists have studied and detected black holes without having to actually see them directly is by seeing their influence. Even before we fully knew that it was exactly a black hole, you could see, well, there's this point in space, an object probably, that has such intense gravity that it's warping gas and stars around it, pulling them in, moving things closer to it. So even though we weren't able to see the black holes directly, we could see their influence. We see this continually with the discovery of exoplanets and with the continued study and exploration and hopefully eventual full discovery and explanation of dark matter, right? We've never directly observed dark matter, but we can see its influence throughout the cosmos. So it's interesting, astronomy is not always looking at something and studying it, it's seeing what it's doing to space around it. I hope that answers your question a little bit. All right, Javier on Facebook asks, I wonder if we'd feel the pain of spaghettification if the other elements of space hadn't already done us in. So Javier's referring to a phenomenon known as spaghettification, which in astrophysics is the vertical stretching and horizontal compression, like, a piece of spaghetti, of objects into these long, thin spaghetti-like shapes in a very, very strong gravitational field like you might find with a black hole. So again, if you'd somehow survived space, found yourself at the edge of a black hole's event horizon and got just a bit too close, it might be pretty quickly between you getting too close and already being subatomic particles and pulled apart. So I don't know how much you would actually feel. I was reading one scientist thought that if you were aware of the whole process of spaghettification as it was happening to you, often as something is spaghettified, turned into that piece of spaghetti, so to speak, that piece would then break at the weakest point, and they thought that might be right above the hips if it happened to a human. Now, luckily, no humans have ever been spaghettified, no humans have ever been near or in a black hole, but it's interesting to think about and horrifying. Thank you for your question, Javier. All right, and Molly on Twitter asks, is it certain death for me and my crew if our ship were sucked in? Great question. Thankfully, no ship has ever even remotely gotten a little bit close. Thankfully. And yes, almost certainly. Now, unless, again, theoretically, you were sucked into not a black hole, but a wormhole, one side of a wormhole created by two black holes connecting 2 points in space-time, which, again, we don't have proof of or full discovery of yet. Unless you were sucked into a wormhole rather than a black hole, yes, that would be fairly certain death for you and your crew, and, your ship as well. I hate to break it to you, Molly. That is very bad news. I hope you and your crew and your ship are doing okay. So that was all the time we had for questions today, but before I go, let's quickly see what was new in space this week. All right, recently astronauts on the International Space Station completed a spacewalk to install new solar arrays. China launched 3 astronauts to the space station. Scientists spotted a strange blinking star near the center of our Milky Way galaxy. Leaders at the G7 Leaders Summit in Cornwall in the UK agreed that the world needs space junk standards. And lastly, lots of fun spacey video games were announced at this year's E3 Games Conference for those of you who like the more sci-fi, fun, video gamey side of space. So again, this has been Space Chat. Thank you all so much for joining me and for asking me your interesting, inquisitive, brilliant questions. And again, as always, join me next and every Friday. And if you ever have a question about an upcoming topic or otherwise, please ask. I would love to answer your questions, and I'd love to hear if there's a topic you'd like me to cover in the future.